Maybe we have an equation with only one radical expression, but it's not isolated. What should we do then? Well, we're going to follow a very similar sequence of steps to steps that we've followed in the past. We will isolate the radical, then we'll deal with it. In this case, take the nth power of both sides, and then we'll finish solving normally. And because we've taken the nth power of both sides, we should also check for extraneous solutions if n happens to be an even number. So let's see an example of this. Let's suppose we know that the cube root of x plus 2 minus 5 equals negative 6. Notice this radical is not isolated. It's got a negative 5 on that side of the equation with it. What do we need to do to isolate it? We need to get rid of the negative 5. So we'll add 5 to both sides, and we'll see the cube root of x plus 2 is equal to negative 1. Uh-oh, can that happen? Oh yeah, well 3 is odd. Odd roots can be positive numbers or negative numbers. Next, we'll cube both sides. The cube root and the cube will cancel out, and we'll get x plus 2. Negative 1 cubed, that's just negative 1. We finish solving normally, and we note that this can't be an extraneous solution because n was odd. However, we should probably check and make sure that that worked properly. Namely, that the cube root negative 3 plus 2 minus 5 really does work out to negative 6. Negative 3 plus 2 is negative 1. And yeah, the cube root of negative 1 is negative 1. Negative 1 minus 5 does in fact equal negative 6. Let me give you one of these to try as well. Solve the equation 3 times the fourth root of 2x minus 8 plus 4 equals 10. Remember, isolate the radical first. Pause the video and try this now. Alright, well what keeps this radical from being alone? It has this 4. Subtracting 4 from both sides, we'll get 3 times the fourth root of 2x minus 8 is 6. Dividing both sides by 3, we'll get the fourth root 2x minus 8 is 6 divided by 3 is 2. Alright, now the radical is isolated. Now what should we do? Right, get rid of the radical by taking the fourth power of both sides. We choose the fourth power because we want to cancel a fourth root. We get 2x minus 8 is 2 to the fourth, 2, 4, 8, 16. And now that we're rid of the radical, we continue solving normally. Add 8 to both sides. 2x is 24. Divide both sides by 2. X is 12. Now we did take an even power of both sides, so we should go back and check that this was not an extraneous solution. Plugging in, we'll have 3 times the fourth root, 2 times 12 minus 8, all plus 4. And we want to know, does it equal 10? Well, 3 times the fourth root, 2 times 12 is 24, minus 8 is 16. The fourth root of 16 is 2. 3 times 2 plus 4, that's 6 plus 4. That is indeed 10. So, in fact, this is not extraneous.